Hello, this is Trevor. Today we're working on the first request smuggling lab in Portsbigger's Web Security Academy. This time it's a basic CL.TE vulnerability. And let's see, so the front end does not support chunked encoding, and it only allows GET or POST. So we are going to smuggle a request to the backend server so that the next request appears to use gpost. So it sounds like what we should do is send a post, smuggle the letter G, and then send another post so that the second one looks like it's gpost. Sweet. All right. Let's take a look at the lab. And I've created this cheat sheet for request smuggling. It's got a lot of stuff, a lot of info. So we'll use that as we go through these labs. Kind of the first thing I want to do is talk about discovery, right? So it said it's CL.TE, and that means we should try one of these two. Let's start with timing, and I'll just copy all of this out. And let's go here. Please remember to like and subscribe. Leave a comment. Let me know how I'm doing. I would appreciate that. Let's turn on burp and request this again. So we get it in burp. Come on. And let's see, proxy, HTTP history. We'll want this one. I'm going to send this to repeater. Repeater, I am going to paste this stuff just so I have it. And I'm going to change this to a post, just like below. And I'm going to delete everything after host. This should still work. And then we'll add the transfer encoding. And we'll just go like this. Boom. Like that. And what we expect if this site is vulnerable to a CL.TE request smuggling, we expect this response to take a long time, right? So let's send it. And what this is doing is the front end's going to use the content length. So it's going to include up to the A. The back end is going to use the transfer encoding. See how it's taking a long time? It's a good sign. Oh, and we got a timeout. Sweet. So this is a good indicator that this is vulnerable. As I was saying, the back end is going to use transfer encoding. It's going to see the 1 here and expect a 0, and it doesn't receive that. So it's going to wait to send the response until it's got that 0 on a line by its own, on its own. Makes sense? All right, so we have this ready. Let's start our script. We are going to name this lab basic TL vim lab basic CL.TE.py. We'll start with the template as always. And let's see, so we are not going to be able to use requests very much while doing this. We're probably going to, most of the time, we're going to create the requests ourselves. So, and I probably want to create a class for this, but let's start by just writing out what we want the request to look like, right? So def, let's create request text like this, and then message or request text equals, we'll start off with the same stuff we did. So we know we want to post, we know we want HTTP 1.1, and then a carriage return line feed. Request text plus equals. We know we want the host. So host, and host, we're going to have to fill this in. So let's get that as an argument. And then we know we want that on a line by itself, right? Host, yep. Transfer encoding, and then content length. So let's add both of those. We'll just do it the same way we've been doing by adding to here. So DTT content length. And I don't know what we want here. Not yet. This one's easier. Transfer encoding will be chunked. Content length, we need to figure out what's in the body before we can calculate the length. So I'm going to put that at the end, and let's fill out the body. We need a blank line. So request text plus equals RN. We don't need F here. And then we need the body. Request text plus equals. And we'll do, remember, we want to smuggle the letter G, right? So in here, we have CL.TE, so we could do something like this. 0, blank line, and then smuggled. So we'll do 0, blank line, and then what we want to smuggle, which is the letter G, right? That way, the next request, this G gets tacked on to the beginning, and it ends up as G post. That'll be our body. So let's name this, not request test, change word body. And then now that we have that, we can calculate this, which will be len of body. And we need that as a string, not as a number or an integer. Okay. And then we just need to add the body on, except for this one's out of place. Let's remove this and put it there. And let's put the body at the top so it's out of the way, right? So this is our body, which is our payload. We've got all the headers. We've got a blank line. Now we need to add request text plus equals body. We don't have the R in here. Boom, blank line, body, and then that should be it. We may need a blank line at the end. Let's add it. Just like that. All right. I think that's good. Let's start with that. So we need to pass in host. We need the host from the URL. So let's import from, do we want from? Yeah, from URL lib.parse, import URL parse. And then here we can do parsed URL equals blog dot base URL. We need parse URL parse this, and then the host will be the netlock. We've done this in one other video, but so let's do, and we need to return request text, right? Let's do request text equals create request text parsed url.net lock. And let's make sure it looks good by just printing it. We'll start with that. I'm going to make sure I refresh this page so it stays live. We're doing a lot of basic paste. Boom. All right, so we've got post. I don't know. I'm worried about all this space at the end. Everything else looks good, except for all of that. Let's take it out. I'm pretty sure that let's try it like that. Yeah, I like that better. Okay. So this is our request that we want to send. Now, I told you we're not going to be able to use requests. We may be able to. I don't know how. So what I want to do is send it using Python sockets. So I'm going to import socket, and I'm going to import SSL so that we can do it encrypted over SSL. And then I want def send request like that. We'll do, we need to send request text. And then we'll create the sock. This is the socket equals socket dot socket inet socket dot sock stream context equals sl dot sl context sl dot protocol TLS client. This by default is going to validate the certificate, and I don't want that. So I'm going to change some stuff. So it's context.check host name. I'm going to set that to false, and the context dot verify mode, I'm going to set that to ssl.cert none. And then we're going to use that sock. Let's let's organize this a little bit. Context socket, and let's do sock equals context dot wrap sock server host name equals, here we need the host. So I'm going to pass through, I I haven't called this yet, so I'll just pass through the host, and then we'll do sock.connect host. We need the port also. Port. And then we'll send it sock.send all. The request text dot encode. And we need to check the response. Do we? We should do this in a with statement. We'll fix that in just a minute. Sock.close. Okay. So let's try this. What we need right here, we need to call send request. We need to give it the request text, the host, and we need the port, which we don't have yet. So right here, we can do port equals parsed URL dot, I think it's port. Let's do IPython. Do from, what is it? URL lib dot parse import URL parse, and then b equals URL parse https www.google.com b.port b.net block. There we go. Okay, so if we had, let's do, let me try something. Yeah. Okay, so if we had a port specified, we could get it. Because it's using the default port, port is not set. So we need to test for that. Port equals port, right? If port is none, we can also get the scheme, b.scheme, HTTPS. So if, what is this? Parsed URL.scheme equals HTTPS. Then we're going to set the port equals 443. Should be, let's do it as text. How do we do type? Is it? Yeah. So if I do type of c.port integer. That's interesting. I want it as, I'm going to use it here, and I think I need it as a string. So instead of, since the default is an integer, let's pretend like, and we'll normalize here. There. If port is none, if parsed URL.scheme equals HTTP port equals 80. Okay. So we've got the, why do I have host here? I don't want host. Well, I can define that. So host equals parsed URL.net lock and put host here. Okay. And then I need the port. That should send it. And then all we need to do is send another request right after it, that's a post, another post. So let's use, instead of creating one, let's use requests to send the second one. Because we're not smuggling the second one, let's just do request dot post. And proxies, we'll talk about proxies in just a second. But blog dot base URL. We can do, what if we just do blog dot get response blog dot, no, because that would be a get request dot post. We want blog dot base URL. I don't think we want anything there. We probably want to see the response. Resp equals, and we probably want to proxy it, honestly. So proxies equals utils dot proxies and verify equals false. Print resp. Okay. So I think that's it. Hopefully, site is still alive. Come on, still alive. Yes. Okay. Let's try it. String object. Super connect. Oh, crap. I was wrong. It needs to be an integer. My bad. We have no logging for the whole thing, which is super lame. And this is taking too long. We have post, host, response 403. That looks right. Dang it. Text. Let's fix a couple of things. So let's go here, log.info, creating request text. And then, should we print this out? I think we should. Log.info, request text. And here we're going to put it on another line because I don't want it all, I want it separate. So I'm going to put request text here and put F there. And then here I'm going to do log.info sending request. Log.info request sent. I'm probably going overboard. Now, we don't need this print. And we're going to change this to log.info resp.text second request response will be this. We'll F this. And then we'll do blog.is solved. Okay, much better. Sorry for the first one. Yeah! Woo-woo! And look, unrecognized method gpost. Sweet. So, yeah, we did it. Let's check the banner. Boom. Pretty awesome. So, just to recap, we read the instructions, knew it was CL.TE, which means the front end used the content length header, the back end used the transfer encoding header. So we built a request that had both the content length we set for the front end to include everything, so that from the G, all of this got included as the body. Then when the back end received it, it would look and see that it's chunked, see the 0, and decide that's the end of the first request. I can respond to that, and then holds this in the buffer for the next request, which we just did a simple request post here, so that, and then the back end tacked this G, or tacked the next request, appended it to what it had in the buffer, which was G. And that meant that the first line of the second one was G post, which means we got that unrecognized method G post back. Pretty sweet. Yeah, so this one's very cool. Request smuggling is pretty new to me, and I have a lot to learn, so I'm excited to go through these. One thing I did notice when this is like the third time I've tried to make this video, but the first time and the second time I kept running into issues, and that was because I was trying to proxy this request, the one that we send through burp. That didn't work. So burp, speaking of how, request smuggling, burp must use the transfer encoding, because anytime I tried to send it through burp, it would remove everything in the body and leave, and then modify content length, and my request would just be post host content length of 0 with no body. So don't try to proxy these. I send an email to the support for Portswigger to see what I can do, because I would like to proxy this request to help troubleshoot, if I have errors here. So we'll see how that turns out. Anyway, if you have any questions, definitely let me know. Otherwise, I'll see you in the next one. Thanks so much. Goodbye.